My name is Muhammad Alif HAIKAL bin AZAHARI, and today my group and I will be presenting for Lab 1, which is identifying a brake system components. Okay, for today, the main objective of this lab session is to identify a brake system components and to be able to name all parts of brake system assembly. As for the equipments, we need to use the complete brake unit, system brake unit, which is also known to be the similar brake system that we have in our standard car. This is just for us to see the similarities. Okay. Secondly is the multimeter or ammeter. And lastly is by using tools in order to disengage tire, for example by using jack or the wheel wrench. This may ease the process as well as making it easier to understand every part of the brake system assembly well.
Alright, hello everyone. So today I'm going to do the procedure of checking the airtightness booster brake. So right now we're going to start the procedure. Alright, first we're going to start depress the brake pedal several times with the engine off until there is no change in the pedal travel. So depress and hold the pedal, then start the engine. So I'm going to start depress until there is no change in the pedal travel. So as you can see here, I have depressed the pedal brake several times, and this is the limit. So now I'm going to start the engine. So as we can see here, the result, if the pedal goes down slightly, then the operation is normal. So right now the pedal goes down, so that means the operation is normal. Alright, then we start the engine and turn it off after 1 or 2 minutes. Depress the brake pedal several times slowly. So we're going to fast forward to say 1 or 2 minutes, and then we're going to turn off the engine. Okay, alright, so the engine has been turned off. So the result, if the pedal goes down further the first time but gradually rise after the second or third dispersion, the servo is airtight. So as we can see here, the pedal goes down the first time but then gradually rise after the second or third depression. So the servo here is airtight. Alright, so now for the third step, depress the brake pedal while the engine is running, then stop the engine with the pedal depressed. So right now I depress the brake while the engine is running, then I will stop the engine with the pedal depressed. So the result here, if there is no change in the pedal travel after holding the pedal for 30 seconds, the servo is airtight. Alright, so I'm going to shut down the engine. Alright, I had already stopped the engine while the pedal is depressed. So after 30 seconds, there is no change in the pedal travel. So the result is the servo is airtight. So that's all for my part. Thank you.
Hello, my name is Muhammad Jeffrey, and I will continue the procedure on how to check the brake pedal and the adjustment brake pedal height. Okay, first of all, to check the brake pedal and adjustment the brake pedal height, first turn up the carpet under the brake pedal. Okay, and then we measure the brake pedal height from this to the surface like this. Okay, so when we check, the product ASIA that I check is on the standard value, which is 162.8 until 165.8 millimeter. So we will not to adjust the brake pedal height. So if the brake pedal height is not in standard value, so we must adjust the brake pedal height. To adjust the brake pedal height, first disconnect the stop lamp switch connector. This is the blue and the white socket, and then we adjust the brake pedal height by turning the operating rod with with plier. First, we loose the rod lock nut, loosen here, and then we adjust the brake pedal height until the brake pedal height is correct on the standard value. Okay, and then we secure by tightening the lock nut of the operating rod, and then push rod lamp switch in the direction of the pedal stroke until it stop. After that, lift up pedal until the operating rod is fully extended. And the last, connect again the connector of the stop lamp switch that we engage. And lastly, check the stop lamp at the back is it illuminate with the brake pedal unpressed or pressed. After that, we adjust the brake pedal, return back the carpet into the first condition. That's all to adjust and check the brake pedal high.
Hello, my name is Muhammad HAFIZIN ARIF, and I'm going to continue how to disassemble the brake pedal. Check this out. Okay, to disassemble the brake, this is the brake. Okay, for the first step, we have to disengage the pin. So here, this is the pin clip. Over here, we have to pull it out. And then, the second, we have to disconnect the stop lamp switch connector, which is this, over here. To disengage this, we have to pull the white socket out from the switch, and then we have to remove the brake pedal shaft. This is the brake pedal shaft. Here we have to loose the nut first using the 12 wrench. Then we can remove this brake pedal. And lastly, we can remove the pedal brake. That's all on the procedure of how to remove the brake pedal. That's all from me, Muhammad HAFIZIN. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif bin AZAHARI. Okay, now I will present about the stop lamp switch check. We need to first prepare the multimeter. Okay, the function of multimeter is to check the continuity of the stop lamp switch. Okay, first we can start by disengaging or pulling out the socket. Okay, here, the blue color. Okay, secondly, we can now connect the multimeter to the stop lamp switch and check whether or not there is continuity when the plunger of the stop switch is pushed and when it is released. Okay. Okay, when the brake pedal is depressed, as we can see here, the brake lamp will light up, and when the brake pedal is released, the light will turn off. Okay, that's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Harith bin MAJID. So I will continue this part. So firstly we have to jack the car first. Okay, so for the second step we have to loosen the tire first. Okay, we have to loosen the nut first. And then we take out the tire first. Okay, next step, to assemble the brake pad. So we have to loosen the nut, which is the 12 size, and then after we have loosened the nut, so we can pull up the brake caliper, and then we can replace the brake pad to the new one. Okay, next I will show for the bleeding process. Okay, for the bleeding process, first we are going to open the brake fluid reservoir. Okay, next. Next, we're going to remove this cap. We're going to remove this cap and loosen this screw nut. Next, press the brake pedal to pump out the brake fluid until there's no bubble air left in the fluid. For the next process is we have to press the brake pedal while tighten the 8 screw nut to complete the process.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif HAIKAL bin AZAHARI, and I will be presenting for data and findings. Okay, our car model is Pro 2 Azia 1.0, and then the transmission type is 4-speed automatic, and the year manufacture is 2015. Okay, next. Okay, for first part, brake pedal. Usually a brake pedal, when you press your foot down on the brake pedal, the connected lever pushes a piston into the master cylinder, which is filled with hydraulic fluid. Okay, other than that, this hydraulic system multiplies the force of your foot on the brake pedal into enough force to apply the brakes and make the car stop or slowing down the car. Okay, next. Okay, for the next part is a brake rotor. A brake rotor is attached to the axle, usually sliding over the lug that also secure the wheel to the hub. Okay, they provide a contact surface for the brake pads, which is under load, generate friction, convert kinetic energy to heat, and slow down our vehicle to a complete stop. Okay, next. Okay, for next part is a brake pad. Brake pad, usually the main functions apply pressure to the rotor, which is directly connected to each wheel. This pressure creates the friction needed to slow or stop our vehicle. Okay, basically, two brake pads are contained in the brake with their friction surfaces facing the rotor. When the brakes are hydraulically applied, the caliper clamp or squeeze the two pads together onto the spinning rotor to slow and stop the vehicle. Okay, next. Okay, for next part is a brake switch. A brake switch, or we can call it a brake light switch, is an electrical switch that turns our brake light on when you hit the brakes, when you press the pedal brake. Yeah, it's an intelligent part of our braking system and lets the driver behind you know that you are slowing down. Okay, next. Okay, for brake caliper. Brake caliper are a specific component of your braking system that crucial for the function of your brakes. Caliper are found on each wheel and works to squeeze the brake pad against the rotor in an effort to slow the spin of the wheel and get the vehicle to reduce its speed. Okay, lastly for my part, is brake fluid reservoir. The main function of the brake fluid reservoir is a canister connected to your brake master cylinder. As you can see, the brake fluid reservoir, okay, it stores your vehicle brake fluid and protects it from dirt and moisture contamination, helping your car's brake function at optimal level. Okay, that's all from my part. I'll pass to the next presenter, Muhammad HAFIZIN Arif.
Thank you, Muhammad Alif. My name is HAFIZIN Arif, and I will continue the presentation of data and findings. For my present part, the first part is the brake master cylinder. As you can see in the white arrow, indicate the master cylinder position. A master cylinder is an automotive device that applies hydraulic pressure to the braking system. The master cylinder is typically located in the engine compartment, and it's fitted a removable cap to add brake fluid. It feeds brake fluid into the brake circuit to convert the pressure on the brake to the hydraulic pressure. Okay, next. Okay, next part is the brake booster. As in the picture, the big black circular thing is the brake booster, And the function of a brake booster is to reduce the amount of pedal pressure needed for braking. It uses a booster setup to act with a master cylinder to give higher pressure to the brakes and lower pressure to the brake pedal through a brake booster push rod. Okay, next. The next is braided brake hose. For information, this braided brake hose is for the braiding process. Um, Brake hoses are used to deliver braking force to the brake pads via hydraulic pressure and brake fluid. It is important for the brake hose to be flexible to enable the driver to steer and brake effectively, as well as maneuver over and around obstacles. Next. Next is the brake hose, but this time it's located at the master cylinder, and its function is same as before. The function of brake hose is to carry the brake fluid. Next. Okay, for the last part is the brake lamp. It's commonly known the brake light switch on your vehicle to serve as important safety function. When you press the pedal brake, it supplies power to the signal lights at the back of your vehicle to warn the other drivers that you have slowed down your vehicles. Thank you, that's all my parts.
So my name is Muhammad Jeffrey and I will continue on brake system diagram and electronic brake system in this car. So this is the brake system diagram. So we have 7 component in brake system diagram. So first is pedal brake, and then we have brake booster, and then we have master cylinder, and then we have brake fluid reservoir, and then in the brake fluid reservoir we have a brake fluid also, and then we have brake lines and hoses, and last we have disc brake and drum brake. So this is the component in brake system diagram. So the mechanism of the brake system is start with when we press the pedal brake or unpress the pedal brake. So when we press the pedal brake, the brake booster and master cylinder will detect, and then will transfer the hydraulic pressure from the brake fluid through the brake line and the hoses to this brake and drum brake. So uh, the mechanism is transfer the hydraulic pressure from the brake pedal to disc brake or drum brake. Next, I will continue to electronic brake system. So electronic brake system, we have 2 electronic system in this car. So the first thing is ABS. So ABS is stand for anti-lock brake system. So the function of ABS or anti-lock brake system is to prevent the wheels from locking up and allow the driver to steer in a good condition when the emergency brake is applied. So the function is to prevent wheels from locking up and allow the driver to stay in good condition. And then EBD. EBD is stand for electronic brake force distribution. So the EBD function is distribute the braking power or force to all wheel of the car. So the car will brake and in a good condition and the same force. So that's all from me. Thank you.
Okay, for question A for discussion, this lab, the purpose of ESC, static of electronic stability control, is to help a lot in the prevention of a car sliding and preventing the driver from losing control of his or her vehicle when rounding a corner, braking quickly, or performing an abrupt move. Next, the brakes are automatically activated using ESC technology that assists in steering the car in the right direction. Okay, for question B, the difference between a diagonal and a dual split brake system. What is a diagonal? A diagonal is a dual circuit braking system in which each brake circuit of one front wheel and opposite rear wheel is diagonally, so that in case of failure a reasonable balance braking circuit can be achieved. So that the picture of the diagonal split, we go to the dual split when brake lines are made of hydraulic fluid that passes through stiff lines that provide pressure to the braking cylinders in the wheels. A brake line failure might be terrible. Okay, so that's the picture of the front or rear split. Okay, for the last question, C, for this question, this discussion, difference between oversteer and understeer. Oversteer is when the car spins more than the driver desires while maintaining a steady steering input, and oversteer might manifest itself in the form of a tail sliding out or a full spin. When the rear wheels lose traction before the front wheels, oversteer occurs. Acceleration requesting too many rear tires, a fast weight transfer forward with the throttle removed to abruptly brakes, or too much steering input can all cause this. So this picture, the driver, we can know the driver is to to overspin the steering. Okay, for understeer is when an automobile turns less than the driver commands, causing the car to stray from its intended course. When the front wheel loses traction before the rear, this happen. This understeer will happen. Oversteer is more common in rear wheel drive automobile than in front wheel drive cars, but can happen in any drive configuration. Okay, for conclusion, at the end of this lab activity, there are many things that we had learned and observed. We had managed to identify brake system components and to name all parts of brake system assembly. Next, we also had successfully performed several tests of brake performance and brake system maintenance. Last but not least, we can know the difference between a diagonal split brake system and a dual split brake system. Also, difference between oversteer and understeer. And don't forget about the purpose of ESC, standing of electronic stability control. Thank you.